Welcome. In this video, I'm going to demonstrate how to eliminate the parameter of a parametrized curve. Now, if you've been watching the previous videos, this is a third technique. In this technique, we're going to rewrite one or more of these equations, either for the x or for the y parameter. Then we're going to use known identities so that we can eliminate the parameter. Now, when you see trig functions, especially sine and cosine, what should come to mind right away, you should recall, is the Pythagorean identity. That's cosine squared t plus sine squared t equals 1. And you might have seen this with a theta here. It doesn't matter. As long as it's cosine squared of something plus sine squared of that same thing equal to 1. Well, I notice that I have a cosine squared here. So I know that I can rewrite cosine squared. Excuse me, I don't know what's wrong with my pen. There we go. Cosine squared t. I can rewrite that as 1 minus sine squared t. Well, I don't have a sine squared. However, I do have the x parameter equals sine of t. So I can rewrite this as x squared equals sine squared. Okay, so now that I have this, sine squared of t, well, I know that cosine squared equals 1 minus sine squared t. So let's put this all together. So y equals 2 minus cosine squared t. That just came from here. Now I'm going to replace this cosine squared with 1 minus sine squared t. So on the next line, I'll have y equals 2 minus 1 minus sine squared t. Now, before I continue, let's just quickly simplify this. Y is equal to 2 minus 1 plus sine squared t. So y is equal to 1 plus sine squared t. There we are. And now we already know that sine squared is equal to x squared from here. So I'm going to replace that sine squared with an x squared to get y equals 1 plus x squared. So we started with the parametrically defined curve with an x coordinate of sine t and a y coordinate of 2 minus cosine squared t. The parameter in this case was t. And we ended up with this equation, y equals 1 plus x squared. They both represent the same curve, just differently. I hope you found this video helpful.